derivative relationships that you know. Everything about f, f prime, and ooh, f double prime. That's coming later today. Right now, you've got 2 minutes completely on your own to fill in as many of these as you can. If you need to use your notes, feel free, but I would prefer that you don't use your notes. 2 minutes. If f is increasing at x equals c, what do you know about f prime? If f has a relative max at x equals c, what do you know about f prime? Folder, turn around. Nine seconds left.
About 0.
I know you know stuff. I know you know stuff. Hey, cheater. Cheater.
No, I'm done.
You're no. Yeah, you're done. Like I'm gonna see the point. 45 seconds left. You should be able to fill in all of these. On Monday, you have to do all these without your notes.
Wait, so the quiz is about
All right, here we go. Time to feed the teen-aggers. We've got 1, 2, 3, 4, 5, 10. I'm telling everybody about teen-aggers. That's my new favorite word. Okay, we got 11 little boxes up here. I'll take hands from anybody. You can, any of the boxes that you know, but once you participate, you're frozen. Daisy.
For decreasing at x equals c, f of x is above 0.
If f of x is decreasing at x equals c, f prime of x is...
No, I said increasing.
Oh, you said increasing. If f is increasing, then f prime is... Above 0 at x equals c. You have to be specific. I'll take another one. Diego. Ooh, if you got a relative maximum at x equals c, what do you know about f prime? F prime changes from positive to negative at x equals c. Nice job. Hey, quick, in the air, draw in the air for me, please, what a relative max looks like. I want to see. Ooh, okay, some of you are doing this thing, but only Jesus. Look at Jesus. And maybe Jose, but don't look at them for too long. They're weird. Okay. Most of you guys are doing this, but they're also thinking about this kind over here. Nicely done. When I say relative max, I mean both. You have to be thinking about both. Paul, give me another. When f has a cusp point, f prime, derivative does not exist at x equals c. Well done. Cusp point could look like that. It could look like that. It could look like a whole lot of different things. There's more. There's more. Rebecca. If f has a critical point, then f prime of derivative is equal to 0 or does not exist. You need to know both. Well done, Rebecca. Floor. Michelle. Sorry, Michelle. Michelle, give me another one.
For horizontal tangent line.
If f has a horizontal tangent line, then f prime?
F prime equals 0.
Is equal to 0 at x equals c. F prime has a root. Well done. Gerson.
There's a relative minimum at x equals c.
If f has a relative minimum at x equals c, then f prime
Goes from negative to positive.
changes from negative to positive. Oh my gosh, okay, we're doing well. Julissa?
Decreasing, if f is decreasing at x equals c,
Yeah?
then it will have to be below the x-axis. So,
Oh, I stopped listening.
so
What I heard you say was if f is decreasing at x equals c, then it is below the x-axis. I stopped listening at the word it.
f of x is below the x-axis.
Not f of x though.
F prime of x
F prime of x
below the x
is less than 0 below the x-axis at x equals c. Okay, what else we got? Nobody else has the others? Henry?
F of x has a center point at x equals c, f prime of x equals 0, and the sign doesn't change.
F prime of x equals 0 and sign does not change. Well done, Henry. All right, if I have a vertical tangent line, can you guys show me a vertical tangent line? It's been a while. I want to see a vertical tangent line out there. Vertical tangent lines look not, no, that's vertical asymptote, Henry. Okay, vertical tangent line. If you have a vertical tangent line, the slope of a vertical line is undefined. It's undefined. So what we're looking at here is you're going to have a vertical asymptote at x equals c. If your graph has a horizontal asymptote, that means that your graph is flattening out. You're flattening out. What happens to the derivative?
It approaches 0.
Approaches 0. Not equal to 0, but approaches 0 as x approaches infinity. Or this could be as you're approaching negative infinity. But if you have a horizontal asymptote, derivative flattens out. Last, you have a vertical asymptote. If f has a vertical asymptote, your derivative has a vertical asymptote. Once you have a vertical asymptote, it stays with you in all the derivatives. These are the 1, 2, 3, 4, 5, 10, 11 facts that just have to be memorized. You gotta get these on lockdown. Monday, as soon as you guys come in, there's gonna be a little quiz. And how I know, I'm so excited. All right, Andy, we're good? All right, now it's time for the push. Oh, I love pushing teenagers.
Off bridge.
Not off a bridge. No. No, I think that's illegal in some places. In some places. All right, so here's where we're going. This is the new game. This is how we're going to continue to grow your skills. I've got these 9 statements down here on page 20. You are going to have to decide if these statements are true or false. You're going to have to back it up and tell me why it's true or why it's false. We're not going to do this thing that I saw my daughter do, and I was so upset at her. She had a whole bunch of true-false questions to do in U.S. history the other night, and those were her answers. And do we know why?
Yeah.
Why?
Because you could easily turn that into a T or an F.
While you're grading, you're like, yeah, true. Oh, no, it's false. Yeah, no. No. All your answers are true because or false because. None of this fake T, fake F nonsense. I was horrified, and she's like, oh my God, Dad, you know? I'm like, yes, I know these things. All right. Diego, can you read the introduction?
Wait, how old are you?
13 and 9. Okay, Diego.
Shown below is the graphic derivative of a function f. The graph of f prime of x roots.
My bad. My bad, what's that word?
Roots.
Roots.
X equals 1 and x equals 5. Use the graph of f prime of x. Determine which statements are true and which statements are false. When determining the truth of value of each statement, you must justify your decision. All justifications must be based on the value that are correct.
Okay, excellent. Welcome to the free response part of the test.
Yay.
Yay! We got this. Okay, so I've given you a graph, and then I'm going to ask you a whole bunch of questions. We're just going to do 1 or 2 together, and then you guys are going to work in your teams here. So, statement number 1, the graph of f is decreasing on the interval 1, 5.
True.
I've heard false.
More false than true.
I've heard true. I've just heard it's more false than true.
Yes.
Number one, I didn't hear a single person say the because. Now you said because. Thank you, Paul. Thank you, Paul. Here is the mission critical piece, and if you don't click to this, you're doomed. You need to know what graph you're looking at. What graph are you looking at? I am tricky. I am gonna, it's like the shell and peanut game here. Marilyn, what graph is this? This is f prime. Shown below is the graph of the derivative of a function f prime. F prime. I've had students that when they get to problems like this, they are writing f prime all over the place because they don't want to get this wrong. This is f prime. Now let's look at number one again. Hold on, Sylvia. Number one, the graph of f is decreasing on the interval 1, 5. How could I ever make a determination about f? I don't see f, I see f prime. Paul.
Those rules.
Those rules. What rules?
Since the derivative is below the x-axis.
Yep.
F(x).
Okay, we're looking for where f is decreasing. What does this mean about f prime? F prime is below the x-axis, f prime is below the x-axis, f prime is negative. So let's read it again. The graph of f prime is less than 0 on the interval 1, 5.
That's true.
Look at that graph.
True.
This is the graph of f prime. From 1 to 5 is the graph of f prime below the x-axis.
Yes.
Yes, so your answer here?
True.
True.
Because
True because f prime is less than 0 for the interval 1, 5. It's not just true and false, it has to be true because and false because. And your arguments are going to go back over here. All right. Number 2, this is the last one we're going to do together, and you guys are going to get some practice. The graph of f double prime will have roots at -2 and 0, but nowhere else. Now I'm going a little cray-cray. F double prime. Evel, what are your thoughts here?
I think it's false because it also has a root between x and x equals 4.
How on earth are you coming up with that, Evel?
Because
I don't disagree with you, but tell me why.
I'm just looking at it like a regular graph. So
Yep.
for the derivative of a derivative, you just look at the minimum.
So f double prime, what I hear you say is that this is the derivative of f prime of x that I'm asking about? Not f prime, but the derivative of this graph, the slope of this graph. F double prime is going to have roots at -2 and 0. Why is f double prime going to have a root at -2? There's a word, there's a phrase I'm looking for. Diego, what's the phrase? F prime has a horizontal tangent line. You've got a horizontal tangent, which means that the derivative of f prime is going to be equal to 0. Anywhere else? At 0, there's going to be a horizontal tangent line. I clearly need to get rid of this marker. Anywhere else? Jalissa, where else?
between 3 and 4.
At this point between 3 and 4, right? You've got another horizontal tangent line. Are all the friends okay with this? Okay, so Adrian, what's our answer here?
True.
The graph of f double prime has roots at -2 and 0, but nowhere else.
Oh, wait, false.
False because?
Because we're gonna have a root at between 3 and 4.
Okay, you could also say false because f prime has 3 horizontal tangent lines. You could also say because there's a horizontal tangent line somewhere over here between 3 and 4, all these things are good, all these things work. Everybody get this under control? Henry?
So like, can't those also be relative maxes and
They are relative, that's a relative max and that's a relative min for f prime. The trick here is I was asking you about f double prime. Okay, so with that said, you guys have the next 7 minutes. See what you can do with the remaining 7 true false questions. It's true because and false because.
With x decreases, then find the graph of fx is increasing.
This marker is no good anymore.
Yeah.
Yeah, because if you look at this part, like it compares the line above the x-axis. I think I say true because f prime is above the x-axis.
No, but it'll be a minimum on the other graph because it's a vertical.
What do you guys think?
Yeah, true because f prime is the comparing
Reach true because above 0, right?
all these values, all the x values greater than true because if the prime is greater than 0. The graph, if an x will have a relative maximum value, how do you find maximum?
To look at the point, I don't think so.
But like I don't think. But it's regular.
Yeah.
No, but how do you know like it has a relative maximum?
It doesn't, because you just look at the root.
Thank you for following my instructions. That's why I know I chose well. Okay?
When you go prime, it doesn't give us maybe right now what I'm thinking is like if it's a relative maximum it means it's negative, right? So there's one at x.
It's a false.
So it wasn't the original graph.
When it has is that x
Have a relative maximum of 0. Prime, so the limit is that. More than that.
Say that positive. Okay. Like before this,
You will know
for
this
to be
is
true.
relative maximum because it goes to a positive.
yeah, so x equals 1
F prime equals x, right? Okay, so
for x
if
false
have a relative maximum.
in the graph, like how do you make that false because x equals 1 is the relative maximum of f of x?
that's it. But false because it's a negative. Yeah, it's one that dude, you still
True.
So that's not the thing.
I mean, yeah, false.
You're thinking about
because it's looking at x equals 0.
relative max. That looks like that.
The relative maximum at x equals 0. So I put false because the relative max of f will be at x equals 1.
That problem is, you're forgetting what graph of x equals because we're looking at f prime. I'm asking about that. Let's f is a relative maximum.
We actually need to
Had a match.
Because remember what we did here?
This is f prime.
That's what we
Partially.
but it's increasing.
Partially, but there's some simple.
I know it's
One minute.
Oh no, that's true.
And the median is like 2
My God.
Why wouldn't we do these things?
Okay,
We do hard things all the time. Challenge with a smile. Did you
what
listen?
about this?
I mean, no,
I'll figure it out.
Yeah, the maximum degree is
Put that.
Thank you very much.
I'm not trying to do this.
Oh, that's like the, because it's,
Does that look more?
horizontal distribution.
Alrighty, let's do it. Oh, perfect. Let's get some brave souls. I either get volunteers or I get victims. For all values of x with x greater than 5, the graph of f of x is increasing. Oh my God, Sheila.
That's true because f prime is greater than 0 for x is greater than 1.
Sheila, I could not have said that better myself. This is a true statement because for f to be increasing, f prime has to be positive. This is the graph of f prime, and I can see that for x values greater than 5, f prime is positive. Love it. Full points. Number 4, the graph of f will have a relative maximum at x equals 0. Daisy.
We said false
False.
because the relative max of f of x will be at x equals 1. Since at x equals 1 is changing from positive to negative.
Okay. The important thing here is that if f has a relative max, what I heard you say is that f prime changes from positive to negative, above the x-axis to below the x-axis. Is that happening at 0?
no.
At 0, and now some people were like, yeah, it's true, there's a relative max. F prime has a relative max, but I'm asking about f, the graph you don't see. So does f prime change from being positive to being negative at 0? No. So I'd say false because f prime does not change from positive to negative at x equals 0. Daisy, I heard you say, but that happens at x equals 1. That's true, but you need to focus on x equals 0.
Okay.
Henry.
Number 5.
Yep.
True because f prime of x does change from positive to negative at x equals 0.
X.
X equals 1.
Okay. So statement number 5, the graph of f has a relative maximum at x equals 1. That is true. I can go to the graph of f prime. I see the change from positive to negative. Love. Number 6, the graph of f is differentiable at negative 2. Differentiable? Differentiable. Differentiable means something to us. What does it mean?
It has to be continuous,
The graph of f has to be continuous.
no vertical axis.
No vertical tangent lines and no cusp points. But here's the problem. You don't see the graph of f. You see f prime. What does it mean for a graph to be differentiable? The limit on the derivatives, that's true. But to be differentiable, I think we're overthinking it. To be differentiable just means the derivative exists. Right? That's what differentiable is, a fancy way to say the derivative exists. So my question to you all is, does the derivative exist?
Yes.
How do we know? Oh, there it is. So this is true because f prime of x exists at x equals negative 2. I think we're only going to do one more. The graph of f has a relative minimum at x equals negative 2. X equals negative 2? Relative minimum? How many guys are going to go for true? How many guys are going to go for false? Okay, that's only like 4 people out of 23. How many of y'all have no idea? Okay, talk to somebody near you. How are you going to make this decision? The graph of f has a relative minimum at x equals negative 2. Go back to your notes. Relative.
It should have like positive
The graph of f has a relative minimum value at x equals 2. This statement is false. It has to be false. This is false because f prime of x does not change negative to positive at x equals negative 2. Now, if you're really astute, if you're really in the game here, you know what kind of point f has at x equals negative 2. Look at f prime. F prime is equal to 0 at negative 2. F prime is positive before. F prime is positive after. We have a fancy word for that. Saddle point. Your graph has a saddle point, and Yvel wants to ride the horse. Okay, good. Yeah. You guys are so good. I love the second period class because you guys are always asking questions about like what's next without even knowing about what's next. It is. Way to pick up what I was putting down there. So this is the graph of f prime, and a lot of you are like, but what does f look like? Coming up with the graph of f is really hard. It's going to require some advanced thinking. That's Monday. Don't be absent. Okay.
Yay, Monday.
All right. Time to push. More pushing.
Up the bridge?
Not off the bridge, just more pushing.
Up the bridge?
Okay, for this pushing, you're going to want either a ruler or an index card. And my hope is that this is going to be the first class ever that figures out concavity. Not Khan Academy. Not Khan Academy. Okay. So, here we go. On top of page 21. In Algebra 2 and Pre-Calculus, we use the terms concave up and concave down to describe parabolas. And I know that you guys know these phrases, because if I said, can you show me what a concave up parabola looks like, you guys are all going to draw the same thing there. Concave up. Concave up kind of looks like this, right? A cup that would hold water. And concave down looks like that. But you only ever talked about concavity in the world of parabolas. Your brains were not ready to have these conversations about concavity with other functions. They are now. So although we could have used these terms to describe other families of functions, we've restricted ourselves to parabolas because their concavity is the same. A parabola has one type of concavity all the time. Graphs that have a change in their concavity, where the change happens, we call the point of inflection. What was that word again? Point of inflection. Let's look at this graph over here. Is there a point of inflection? Chris, what I'm really asking is there a place where the graph changes from concave up to concave down?
Yes. Yeah.
Now, where is it exactly is not a conversation that we're really ready for. But are we okay that, like, we see concave down over here, and we see concave up over here, and somewhere over here there's a change? I will tell you, because I made this graph specially for you guys, it's happening at x equals 0. At x equals 0, this is the point of inflection, not point of infection, point of inflection. All that I'm saying is concavity changes. Here, it's a change from concave down to concave up. Okay.
What is it?
Concave, C-O-N-C-A-V-E. Concave down before the point of inflection, concave up after the point of inflection. You can have multiple points of inflection. It's possible you have no point of inflection. It's all good. All right, so here we go. This is where you're going to want a ruler. For the graph shown above, identify an interval where the original function is concave up. Concave up. We got that? Check. What I want you to do is with a ruler or an index card, create some tangent lines to the graph. Make some tangent lines for me to your graph. Make them good ones. Use an index card or a ruler. Let the OCD take control. Just a bunch. Now, for those of you like, oh, what's a bunch? Okay. Tangent lines. So I'm going to draw some tangent lines. Oh, there's one. There's one. There's one. Just a whole bunch of lines. They're going to touch the graph one time only. We don't want to go through the graph. But if you're thinking about like, hey, this tangent line, it's going to intersect this graph eventually. If you need to adjust the thought to tangent line segment, that's fine. Tangent line, we're just sort of saying generic. Okay. Everybody good with the tangent lines? There's something I want you to notice about the tangent lines. There's a bunch of somethings I want you to notice about the tangent lines. Anybody notice anything about the tangent lines? I'm not going to tell you yet. I want you to dangle for a little bit. Is there anything you notice about every single one of those tangent lines? Marilyn, what do you notice? Oh, you're a big tease. You're like, no, never mind. Anything that anybody notices about all these tangent lines? I see Abel, I see Diego. Diego, what do you notice?
They're around the maximum.
Okay, I chose to draw them around the maximum or the minimum, but I could also draw them up here. It is true that they are around the maximum or the minimum. Yvel, what do you see?
That they intersect each other?
They intersect each other. It does kind of look like a whole bunch of sticks sort of lying on top of each other. Andy?
Whenever the graph is going down, the tangent line is going down.
Whenever the graph is going down, the tangent line is going down, you said?
Yeah.
And when the graph is going up, the tangent lines are going up? Hopefully that's not too much of a surprise, right? If the graph is increasing, the tangent line has a positive slope. I have never figured out how to get anybody to like really see what I'm hoping for here.
Triangles.
More triangles?
Yeah.
The shape of the graph.
Okay. Stay with me. What's the slope of this tangent line?
1.
Oh my God.
Negative
The
1.
slope?
Negative 1.
Okay, now I don't know that anybody should be betting that it's -1. It's negative something. Negative something, right? How about over here?
Negative something.
Negative. More negative or less negative?
Less negative.
More
negative.
Oh, less.
Over here.
Less negative.
Over here, less negative, right?
Yes.
How about over here?
Less.
Over here?
That's not even.
Here, you're at 0, right? Over here? Over here?
More positive.
More positive over here?
The most positive.
More positive, more positive, more positive. Check out those tangent lines one more time. The slope is negative, and then you said less negative than 0. Then positive, more positive, more positive, more positive. The slopes are increasing. The slopes of the tangent line are increasing. Now that I've said it, does everybody see that? We're okay with this? They're increasing. What that means is that if f, or at least on this example, if f is concave up, what I can say is that f prime, the slope of the tangent line, f prime is increasing. Those slope values increase. Well, if f prime is increasing, and I take another derivative, f prime is increasing, what about the derivative? F double prime isn't going to be increasing. F double prime is going to be above the x-axis. F double prime is positive. If f is concave up, the slopes of those tangent lines are increasing. And that means that the second derivative is positive. Hold on, Paul. To help you guys keep this in your brains, concave up. My hope is that that makes it a little stickier now. Why?
Because both sides are positive.
Right, this guy here is supposed to be telling you concave up. And why would I put the 2 plus signs?
Because they're increasing.
Why would I put
First it's
2
increasing,
plus signs?
And then the second time it's still positive.
2 because it's the second derivative. The plus signs were above the x-axis.
Did you come up with that?
Yes. Shut up. If f is concave up, f prime is increasing. If f prime is increasing, then f double prime is positive. Now there's one more thing about the tangent lines and where they're located. Every single tangent line that I drew, every single one of them, not greater than 0. They're all below the graph. They're under the graph. So the way I like to try to remember that is draw a little tangent line and just like sort of draw it on there. It's below the graph. And what that means is when we loop back around to doing things like using the tangent line to estimate the value of the function, if those tangent lines are below the graph, guess what's going to happen? What kind of an estimate are you going to get? If all your tangent lines are below the graph, you're going to get an underestimate. Right? Because the tangent line is above the graph. Okay? So if the graph is concave up, f prime is increasing. That means the second derivative is positive. Those tangent lines are below the graph, so you're going to be getting underestimates all the time. Run through the same process with the part of the graph where f is concave up. Let's see if you can go through and get the argument. Did I just say concave up? I meant concave down, sorry. Concave down.
I mean, f prime.
Draw those tangent lines if you need to. Hey, man.
Because it's a concave down. That means negative,
You
negative.
talk about f triple prime as well. There's no stopping you, Paul. So I wouldn't be having conversations about increasing and decreasing with f triple prime. You can find f triple prime. What it tells you about the graph is something different. Okay?
Overestimate.
Alright, concave down. I'm drawing my tangent lines, I'm drawing my tangent lines, I'm drawing my tangent lines. What I hope is that in the world of concave down, so f is concave down. What do we know about f prime? All those slopes, positive, less positive, 0, negative, more negative, f prime is decreasing. And so f double prime
It's below the x-axis.
is below the x-axis or negative, but I love the fact that we're saying below the x-axis. I think that's a really good choice. Okay? The little image that you might want to use this time, concave down, double negative. It looks like it. Sure, it looks like a cat. Okay, this little part to say concave down. The little negatives to say second derivative is negative. Now what about those tangent lines?
It's above.
They're all above. So it looks like my cat just got a piercing of some sort. Okay? So those tangent lines are above the graph. So what about the estimate? Overestimate. We got this? We really have this under control? Excellent. So I can make the quiz on Monday harder? I can't wait. Oh my God, it's going to be so good. So good, Mr. Harper. I got them right where I want them.
On the edge of the bridge.
All right. Oddly enough, we have 8 minutes left. I'm thrilled because what I can do is you guys can start on the homework. And I might even be kind and show you how to do one of these. Yay! Okay.
Are you gonna pick this up here? Right?
Yes, I'm going to pick it up. So if you could do it on a different piece of paper, that'd be great. All right. My friends, the first 6 questions are going to be calculator active, which means you best have your calculator handy. Best have that calculator handy. Okay, number 1, f prime is equal to 5x to the 4th minus 20x cubed plus 10. Identify the intervals for which the graph of f will be concave up. Excellent. This is what I don't want to have happen to you this weekend when you're like, what the? Okay? You can graph it. This is f prime. Graph f prime. But be careful with the graphing of f prime. Because I want to know when f is going to be concave up. What you're going to have in front of you is f prime. How would you decide where f is concave up? Karina, what are your thoughts here?
Well, I was thinking of working backwards with the, you know how we had the derivative?
Yeah.
Like I thought it would be x to the 5th power minus.
Oh, that's some really good thinking. So you're wanting to go backwards. You want to say, if this is f prime, where did the derivative come from? I like that. That's not a bad idea at all. That's a good strategy. What else you got?
Wait, Mr. But what if in the f of x you have a constant, but it won't appear?
Oh my God, you wouldn't know what the constant is. Good deep thoughts. We're going to get back to that in December.
What?
For real. You know.
Can you look for the roots?
Look for the roots. The roots of what?
The derivative function, because when x equals 0, that means there's a horizontal tangent line of x.
Okay, first of all, get this graph. Get the graph sketched. Get the graph sketched. There's so many good ideas. I don't know that any of them are really going to get us where we want to be, but man, there are some good ideas happening here, Gonzalo. What you have in front of you is the graph of f prime. I want to know when f is concave up. If f is concave up, there's something you know about the graph of f prime. If f is concave up, the thing that we know about f prime, not negative. F is concave up. I'm hearing above 0, but that's the problem. That's f double prime. What you have a graph of is the graph of f prime. What do we know about f prime? F is concave up. What's true about f prime?
It's positive.
Not positive. Go back to
It's
your notes.
increasing.
Increasing. If f is concave up, then f prime is increasing. The things you guys said were true. F double prime is positive, but you don't have a graph of F double prime in front of you. What you have is a graph of F prime. Does anybody have a graph on their calculator? Okay. So on Karina's calculator, the graph looks something like that. Is everybody seeing something like that?
Yeah.
So if that's the graph of F prime, where's F prime increasing?
From 0 to from 3.
Okay, clearly starting at x equals 0. And how long does it increase for? To infinity? Are we sure? Yeah?
Is it really, like, mine doesn't look, it looks like it's more on one side.
It's like it's more on one side.
So it doesn't go towards, like, in between origins.
Okay, I want to get a couple more graphs because... Okay, yeah, so we're getting like really flat graphs. Yeah, really flat graphs that look like that. I think there's a mistake here. Change that to x greater than 0, please. Change it to x greater than 0. Okay, the key is what you have in front of you is the graph of f prime, the derivative. You're making determinations about concavity by saying where is f prime increasing. So you need to look at the graph of f prime. All right, one more. Let's see what we can do here. 1 through 6, I need you to know these are all calculator active questions. I want you to sketch the graph. And so for number 2, f prime is 6x minus 3x squared. The graph of f has a relative maximum where? How would I figure out relative maximum? What has to happen with f prime if you have a relative maximum? F has a relative maximum.
It has to go from positive to, yeah, positive.
F prime. F prime has to go from positive to
Yeah,
negative.
F prime has to do that.
F prime is what changes from positive to negative. So you're looking for a root where the graph changes from positive to negative. Okay, hold on. Here's what I want you guys to do this weekend. Just do 1 through 6. Don't do the bonus questions on the back. We're not there yet. I don't want to go so fast that I make you miserable. Not sure why Adrian's packing up yet. That seems like a really bad choice there, Adrian. But I love you. Okay, 1 through 6, they're all calculator active. Show the work. Yes, I'm going to pick this up on Monday. Use the calculator. Monday when you guys walk in, there's going to be a quiz on all these f prime, f double prime relationships. It'll be 10 questions. You have 6 minutes to do all 10 questions. Okay, Andy? The answer would have been A, 1 only.
For the quiz,
Yep.
do you get to use your calculator?
Do you get to use calculator on the quiz? No. No. Sorry.
So you're
Okay. See y'all later.
Is it just like